Hello and welcome to the third video of the FP1 chapter Complex Numbers. As usual, start on the screen, pause the video if you've got time and give this a go to review our previous work. First one here, Z plus W plus the complex conjugate of W. So remember, the complex conjugate just replaces the symbol for the imaginary part with its opposite. So instead of plus here, we have a minus. So this gives us 3 minus 9i plus 2 plus 7i plus 2 minus 7i. So we end up with 7 minus 9i. Similarly, for the complex conjugate of Z, we replace the minus 9i with a plus 9i. And then we're multiplying this by W. Expand the brackets in the usual way. We get a 6, then we have 18i and 21i, and then we have 63i squared, which becomes a minus 1, so that becomes minus 63, which gives us minus 57 plus 39i. Third and final one, Z divided by the complex conjugate of W is 3 minus 9i divided by 2 minus 7i, and to put this into the usual form a plus bi, we need to multiply by the conjugate of the thing on the bottom, which takes us back to W, 2 plus 7i. And then we follow this through, 6 minus 18i plus 21i minus 63i squared, all divided by 4 plus 49. And remember, this is coming from minus 7i times 7i, which gives minus 49i squared, which gives plus 49, and the two other I terms cancel out. And all of that simplifies to 69 plus 3i divided by 53. And the reason you would normally do this is to write it like this. In this video, we're going to look at Argand diagrams, drawing them, and a little bit of interpretation. It's a fairly short video, but it leads in very nicely to the next video looking at this. So what is an Argand diagram? Well, to explain this, we're going to start with a simple number line. And this is the number line of real numbers. And of course, any number in the world that is a real number, you can find somewhere on this line. But if we have a second dimension to this, an imaginary part to our number, we can draw it like this. And yes, it looks very much like a Cartesian graph, and yes, you'll be happy to hear it acts very much like a Cartesian graph, but do not call it a graph. Call it an Argand diagram. It has a real axis and an imaginary axis, and uses all of the usual graph conventions for points and vectors. For example, here we have a point, and you would read this as 5 plus 2i. And that is the complex number represented by that point. Or you could have an arrow and a point. Just a point. Here we have minus 3 minus 6i, or just an arrow. Here we have minus 6 plus 4i. So we have three complex numbers represented on this diagram. I hope this is fairly obvious. If we're using it like a graph, then the point P, X, Y, the coordinates, are representing the real part and the imaginary part here of the complex number Z. I'll do the opposite here. Complex numbers are given, now I'm going to plot them. So Z1 is minus 4 plus I, so I will put that as a point here. Then we have 2 plus 3i, put that as a point here. And Z3, 2 minus 3i, down here. Now it's useful to note that Z3 and Z2 form a complex conjugate pair. This is the conjugate of this, and this is the conjugate of this. Geometrically on an Argand diagram, that is seen by a reflection in the real axis, for the obvious reason that the real value has not changed, and the imaginary value has changed sign from positive to negative, or negative to positive. In the same way, we can represent addition of complex numbers on an Argand diagram. So here we have Z1, 4 plus I. Let me put that as an arrow here. And Z2, 3 plus 3I. Now the addition of Z1 plus Z2 works like a vector addition on a normal graph. So you would put your 3 plus 3I over here, and I'm not going to write Z2 here, because Z2, the point is here, from here to here, but the green arrow represents effectively plus Z2. So if you're going to add Z2 onto Z1, it can go there. The final vector addition here, Z1 plus Z2 in blue. So your vector addition rules still apply here. In much the same way, we can do a subtraction, which you know is just the addition of a negative. So we have Z1 2 plus 5I is about here, and Z2 4 plus 2I. And then if I want to do Z1 minus Z2, I can put Z2 head to head with Z1, like so. And in green, I have Z1 minus Z2. And that's it for the introduction of Argand diagrams. We use them a lot more as the chapter goes forward, but for now, that's enough for you to have a go at questions in exercise 1E. And maybe I'll see you in the next video.